We're going to finish up factoring by factoring some special products. So let's go back and review what the special products were. The first one was called a perfect squared trinomial, and the second one was the difference of two squares. I'm sure you've heard me refer to as just the difference of squares. Now, how did we make a perfect square trinomial? Well, we squared a binomial. So in this case, I'm squaring x plus 3. We actually learned a little shortcut, but let's do the long way first. I actually told you to take it and write it as the 2 and to use FOIL. Okay, so that's going to give me first, outer, inner, and last. And what do you know about the outers and inners? What do you notice about them? They are the same, so there's 2 of the 3 x's, so that's x squared plus 6x plus 9. Now, the shortcut for this is square the first term, multiply these 2 together, which is 3x, but take 2 of those and square the last term, and you'll see you get the exact same answer. So if you know this, then we can turn around and we can start recognizing perfect square trinomials. And then factoring them is easy because you know it's going to be a binomial square. So how can you tell if something is a perfect square trinomial? Well, the first term and the last terms will be perfect squares. The middle term is 2 times the factor from the first term times the factor from the last term. So by factors here, they're not asking you to give a choice. They're asking you to basically take the square root. So I take a 3x from the front and a 2 from the back, multiply those together times 2, and I get the middle term. So again, it's going to be a perfect square in the front, a perfect square in the back, and this is going to be 2 times the square root from the front times the square root from the back. So let's see if we can recognize them. Ready? Perfect square in the front, perfect square in the back. So what I do is write their square roots. 3x and 8. Multiply those together, which is 24x times 2 means the middle term should be a 48x. Is it? No, it is not. That means this is not a perfect square trinomial. Ready? Perfect square in the front, square root is 9x. Perfect square in the back, square root is 5. Multiply these together, that's 45. X times 2 is 90x. Is that the middle term? Yes, it is. So all I have to do is take these 2 square roots that I already pulled out, the sign in the middle, 9x plus 5, and put a little 2 on the outside, and there it is factored. Look how easy that is, okay? Now you might want to pause the video and try these. Okay, and again, I'm going to go ahead and do those, so pause the video. Perfect square, not a perfect square. Move on. Perfect square, x, perfect square, 2. Multiply those together. 2x times 2 equals 4x. Yes, this is a perfect square trinomial. Factor it. Just use what you did on the top here, these square roots. X, sign in the middle, plus 2 squared. Okay, next one. Perfect square, yes, square root is x. Perfect square, yes, square root is 7. Multiply those 2 together, that's 7x times 2 is 14x. Is that what's in the middle? Yes, it is. Put your parentheses, take your x, take your 7, use the sign in the middle, and put a little 2. Oh, factoring's awesome. Okay, ready? Perfect square, yes, that's 3x. Perfect square, yes, that's 2. Multiply these 2 together, 6x times 2 means that middle term needs to be 12x. It is not, so that's not a perfect square trinomial. Doesn't mean it can't be factored, just means it's not a perfect square trinomial, so it's not an easy one. So the next one was called the difference of squares, or the difference of two squares. And again, how did we make that? Well, we had something that looked like this. Remember, the two binomials looked exactly the same except for one was plus and one was minus. When we used FOIL here, we got x squared minus 3x plus 3x minus 9. The outers and the inners always canceled out in a case like this, and we ended up with x squared minus 9. So how do we recognize that? Very easy. There are two terms, that's the binomial, that are perfect squares, and they are subtracted. So two perfect squares subtracted. This is the easiest one to recognize. All right, ready? Perfect square? Yes. Perfect square? Yes. Don't be fooled because the exponent is 4. You just take half of it. So what you do is the square root of this is 3p. No. Let's go back. Ms. Wilbur goofed. That is not a perfect square, so that cannot be factored using this method. What was I thinking? Silly me. Ready? Perfect square. Yes. What's the square root? 10x. Perfect squared. Yes. What's the square root? 2y. Put two of those. X, 2y. One with a plus, one with a minus. Okay? Ready? Perfect square. Yes. Square root is x squared. Perfect square? Yes. Square root is 5y cubed. Okay, again, as long as the exponent is even, then it's a perfect square. All right, put your two parentheses. 1 plus, 1 minus. X squared goes in the front spot. 5y cubed goes in the second spot. Okay, this one's tricky. Is 1 a perfect square? Yes. Square root is 1. Is 4x squared a perfect square? Yes. It's 2x. Is that a subtraction sign? Yes. Put your two parentheses. You've got 1 plus 2x, 1 minus 2x. Again, the whole thing with these is that if you recognize that it's the difference of squares, it's so much easier to factor. All right, perfect square, yes. Square root is p to the 4th. Perfect square, yes. 7q to the 3rd. Put your two parentheses, subtraction sign in the middle. P to the 4th minus 7q to the 3rd. P to the 4th plus 7q to the 3rd. You'll notice that I switched those that time. Doesn't make any difference. Just wanted you to see that. All right, last one. Perfect square, yes. Square root is 4x. Perfect squared, no, because that's a 5. Okay? And that's it.